Today we are going to cover section 1.3 and 1.4, linear functions and equations of lines. So take the time to copy your title and your essential question. How do you use linear regression to find trends in data? Go and paste your cutout, copy example number 1, pause it, and we'll start once you're ready. And take the time to read the cutout as well and highlight any key things. Go and pause it. A function f defined by f of x equals mx plus b, where m and b are real numbers, it's a linear function. We know that the value of m represents the constant rate of change, which we know that is the slope. But something to keep in mind is that your slope is also your rate of change, and because it's a linear function, it has to be constant throughout. The value of b represents your initial amount, or the initial value of f of x, when x equal to 0. We also know that the b is called the y-intercept. So let's go through example number 1. Let's go and make a 5 by 5 graph. Go and cut 245, 245. And you've done this before. You graph back from 8th grade. That's when we first introduced graphing on an x and y plane. Make sure that you guys are using a ruler for your graphs. So take the time to graph each one. See what you get and we can compare our answers. Go ahead and pause it. You got it? So in this case, we know that our slope or y-intercept is -2. That is the initial value. So I'm going to go down 2. That is the y-intercept. We know that 3 is your slope. And when we are dealing with the slope, we want to make sure that we make it into a fraction, correct? We also know that your slope is your rise over your run. So therefore, for my initial value, for my y-intercept, I'm going to go positive 3. So I'm going to go up 3, and it's positive 1, so I go to the right one. And you want to make as many points as possible on the graph so I can repeat the process. Since the rate of change is constant, it'll be up 3 to the right one, up 3 to the right one, up 3 to the right one, no more space. Or the opposite, 1, 2, 3, and over 1. Because we know that the slope, which is 3 over 1, can also be written down as -3 over -1. So instead of, I can go down and to the left. And that is our line. For letter B, my y-intercept is 1/2. My slope is -2 over 3, or -2/3. Now, when we think about the slope, we know that our slope is 2/3 is negative. And the negative belongs to the 2 or to the 3. It belongs to either one of them, right? So it can belong to the 2, or we can also think about your slope as 2 over -3. Both of them are equivalent to -2/3. So therefore, I'm going to go down 2, 1, 2, and to the right 3, and 1, 2, 1, 2, 3. I have plenty of space for one more. Or the opposite, 1, 2, and 1, 2, 3. If we think about the slope in this manner. And 1, 2, 1, 2, 3. Make sure that you make as many points as you can on a 5 by 5 graph. Make sure that you guys use the ruler. And we know that that's a positive slope, so your slope should be going up, negative slope should be going down. Now, don't paste your next cutout yet, because we'll need some space before we paste them. But let's go and review. Your x and y intercepts. The x-intercept of the graph y equal to mx plus b. We're going to let y equal to 0 and then solve for x. And to find the y-intercept, we're going to let x equal to 0 and evaluate for y. So in this case, let's go and find your x and y-intercept. To find your x-intercept, we're going to let, because if you notice in this case, we don't know where it crosses. We know that your y-intercept is 0, -2. So we let your x equal to 0. To find your x-intercept, we're going to let your y equal to 0 and solve for x. So let's do so. In this case, your x is what we're looking for. Your y will be 0. So remember that f of x stands for y. So therefore, we're going to replace the f of x with a 0 equals 3x minus 2. And now we can solve for x. So therefore, that gives me 3x equal to 2. So therefore, x equal to 2/3. And which matches. But remember that your x-intercept has to be a point, and your y-intercept has to also be a point. The 0 of a function and x-intercepts. Let f be a function, then any number c in the domain of f, where whenever you plug in the c into the function, if it gives you 0, it's called 0 of the function. And the point c0 is also the x-intercept of the graph. So something to keep in mind is that the 0 of a function is the same thing as your x-intercept. So therefore, this is the 0 of the function. And let's go and label it here. And it goes back to when you guys solve for quadratic equations, correct? So therefore, if I plug in a 2/3 into this function, it should give me 0, correct? And we can check it on the left-hand side. F of 2/3, according to this, if I plug in a 2/3 in the function, 3x minus 2, I'm plugging in 2/3. The 3's cancel, so I end up with 2 minus 2, so it gives me 0. So you want to be able to make all of those connections. That is the x-intercept, which is called the 0, and whenever you plug in a 2/3, will give you 0. So do the same thing for letter B. Find your x-intercept, find your y-intercept. We know that your x-intercept, you're going to plug in a 0 for the y, and we know that to find your y-intercept, you're going to plug in a 0 for the x. Go and pause it, see what you get, and then we can compare answers. So in this case, we know that your y-intercept, we already know that it's 1/2. That is your b value. To find the x-intercept, we're not too clear where it crosses your x-axis. So therefore, we're going to plug in a 0 for the y. That means that f of x is the y value, so that'll be 0 equal to -2/3 plus 1/2. And I forgot my x in there. So I'll move my 2/3 to the left, so it gives me 2/3 x equal to 1/2. I'll multiply by the reciprocal, so it'll be 3/2. So therefore, that gives me x is equal to 3/4. And we can always confirm if that is correct. If we plug in 3/4 into the equation, should give me 1/2. Does it? Well, let me just do it very quickly. So therefore, that gives me f, instead of the x, I'm going to plug in a 3/4. That gives me -2/3. Instead of the x, I'm going to end up with 3/4 plus 1. So it gives me -6/12 plus 1/2. Plus 1/2. That is 1/2, so I end up with 0. So therefore, that is correct. That is the 0 of the function. But we usually don't check it, right? We can assume that we did it correctly. And notice that it does kind of match your graph. It's not going to be perfect because we did it by hand. So go and paste your calcs right below it, and then we can continue with the next example. Go and pause it. Example number 2. Take the time to copy it down or paste it, and we'll start once you are ready. Go and pause it. So take the time to read the problem, then answer each of the questions and see what you get. Go and pause it, work it out. A 100-gallon tank full of water is being drained at a rate of 5 gallons per minute. Write formula for a linear function f that models the number of gallons of water in the tank after x minutes. So therefore x will be corresponding to the number of minutes. We have a 100-gallon tank. That will be your initial amount, which will be your y-intercept, which is your b. And a rate of 5 gallons per minute, that is your rate of change, which is your slope. So therefore, for the first section, for part A, we can write a linear function f. So therefore we have f of x equals, your initial amount is 100, but your rate of change is 5, so therefore there'll be 5x, which x corresponds to the number of minutes, plus your initial amount, which is 100. But I already have an error. So what is my error so far? Correct. It's been drained, so therefore that should be a minus. For part B, how much water is in the tank after 4 minutes? So something to be able to understand is that since x is the number of minutes, I can just plug in a 4 in the function to end up with the amount of water after 4 minutes. So let's go and plug in a 4. So therefore that gives me negative 80 plus negative 20 plus 100, so it'll be 80. So f of 4 will be 80, which means that there'll be 80 gallons after 4 minutes. Use the x and y intercept to graph f, the function, and then interpret the graph. So I'll use this space on the right to be able to graph it. So for part C, I'm going to find your x-intercept and your y-intercept, something that you did on the last problem. So if you haven't done so, go and find them, pause it, and we can compare our answers. So we know that our y-intercept is b, so therefore that'll be 0 and 100. If you plug in a 0 into the function, you end up with 100. To find your y-intercept, we're going to let y equal to 0, which is your f of x function. So therefore, that'll be 0 equal to negative 5x plus 100. The minus 100 on both sides, or just move the 5x to the left. You can say 5x equals to 100, so therefore x is equal to 20. Let's go make a quick sketch, and then we can interpret the intercepts afterwards. Let's see, my x-intercept is 20, 0. My y-intercept is 100. So if I make I think every 10 should be, so 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. So I'm going to make I need to go all the way to 100, so I'm going to make this every 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. And x will be going all the way up to 20. So maybe every 2, 2, 4, 6, 8, 10. 12, 14, 16, 18, 20. Now you want to make sure that you label your x and y axis. Your x corresponds to the number of minutes. And your y will correspond to the number of gallons. And now 20 is your x-intercept, 100 is your y-intercept. So therefore, if it's a constant speed that you're draining the tank, and one of the key things is that, can we go beyond or below zero? No, correct? Because you can't have a negative. So therefore, your x-intercept, or sorry, your y-intercept and your x-intercept. So interpret each intercept. So your y-intercept is your starting value. And what does the x-intercept correspond? Your x-intercept corresponds to how long it takes for the tank to be fully drained. So it will take 20 minutes to drain the tank. And that is your x-intercept. So go and paste your cutout for the constant and the vertical line. A function f of x equal to b, where b is a real number, is a constant function. So every time we have such as f of x equal to 3, we know that that is a horizontal line and that it crosses the y-axis at 0, comma b, in this case 0, comma 3. And it doesn't cross the x-intercept unless b is equal to 0, correct? And then the vertical line, we know that if it's a vertical line with x-intercept, k, comma 0, has an equation of the following form, such as example number 3. So let's go through the process and make a 5x5 graph. We also know that if it's a vertical line, the slope is undefined. We used to say that there's no slope in algebra 1. So take the time to graph each one, see what you get, and we can compare our answers. Go and graph A and B, go and pause it. So for letter A, we know that x equal to -2, that is going to be a vertical line that crosses the x-axis at -2. So therefore, -2, comma 0, your x-intercept. And we know that if we have y equal to 3, or we can be written down as f of x equal to 3, that is a horizontal line where your y-intercept is 0, comma 3. Example number 4. So take the time to paste it, copy it down, and then we can start once you are ready. Go and pause it. So the slope of the line, you guys cover back from 8th grade. Passing through the points, through two distinct points, is given by the following equation. Now, do you remember what this little triangle means? So what is the little triangle? That is the change. The change in y over the change in x. So therefore it will be y2 minus y1 over x2 minus x1. Well, we don't want the denominator to be 0, because otherwise that'll be, the slope will be undefined, which means that your graph will be a vertical line. So a table of the values for a linear function is shown. Determine the slope of the graph of the line. Now we can use the formula to find the slope, correct? But we can also say, well, I know that is the change of y over the change of x. If I look from any points, I can go from the second one to the third. What is the change in x? It increased by 3. And if I think of what is the change in y, it decreased by 2. So therefore, my slope is, the change in y is negative 2 over 3. Or if you want to be able to get two other points, you can go from negative 3 all the way down to 6. The change increased by 9. And I go from 5 all the way to negative 1. It decreased by negative 6. So therefore, my slope is the change in y over the change in x, which is the same thing as negative 2/3. But we can also use the formula. I want to select two given points, so let's select the first one and the second one. And let's go and find the slope. So it's y2, so it'll be, where my first point will be negative 3 and 5, and my second point will be 0 and 3. So therefore, it'll be 3 minus y1, which is 5, then x2 minus x1, which is negative 3. Therefore, that'll be negative 2 over positive 3. And your slope is negative 2/3. So let's go and make a quick sketch. So let's go and make a 5 by 5 graph. And let's go and plot all the points. Negative 3 and positive 5, 0 and 3, 3 and 1, and 6 and negative 1. And notice that this is a straight line, so therefore the slope is constant throughout. It's down 3 and over, down 2 and over 3, down 2 and over 3, down 2 and over 3. Example number 5. Go and paste it, and we can work it out once you are ready. Go and pause it. So we have the points so far. The line with slope m, so we have our slope, and passing through a specific point, has the following equation. And you should be able to realize that this equation comes from the slope formula. So if you have m equals y2 minus y1 over x2 minus x1. If we multiply both sides by then that cancels and end up with my point slope form, correct? X minus x. But in this case, we don't place because we're just going to plug in one number, we just using the first point instead. Now, there are going to be times that it's easier to be able to use this equation to find the equation of the line. There's going to be times that we can use your y is equal to mx plus b. And you need to be able to decide which one will be best to use. If they give me one point in the slope, I prefer to use this equation, even though some of you guys are more comfortable using this one here. But you want to kind of work with both. If they give me the y-intercept, which is my b, then I use my slope-intercept form. So therefore, in this case, because I know that it crosses your y-axis at 3, I know that my b is equal to positive 3. So therefore, we can use this formula where that is positive 3. And then what is your slope? It's down 4 and over 1, so be negative 4. Now, in this equation, do we know the y-intercept? No. So therefore, I should be using this equation because they give you one of the points. Well, they actually give you 2 points, but you can use either one, and I need to be able to find the slope. So let's go and find the slope. What is the slope? Then let's use one of the points. Let's use this point here, which will be 2, 1. Use this equation, solve for y, see what you get for the equation, and then we can check it out. Let's go and pause it. So in this case, your slope, we know it's going to be positive, it's going to be a fraction, so it's going to be up to and over 2, 4, 6. So therefore, it will be 2 over 6, which is 1/3. So therefore, it will be y minus y1, which is 1. My slope is 1/3. Then we have x minus x1, which is 2. And now we can just solve for y because they want us to find the slope-intercept form of the equation. So solve for y, see what you get, and then we can compare our answers. So it gives me y minus 1 equals to 1/3 x minus 2/3 plus 1 on both sides. So it gives me y equals 1/3. What's negative 2/3 plus 1 will give you plus 1/3. So therefore, your y-intercept is 1/3, which matches, and your slope is up 1 into right 3. So I want you guys to make sure that you take the time to be able to see which is the best equation to use. I know that some of you guys are used to just using the mx plus b, the slope-intercept form, but in this class and in calculus, you want to be able to also use your point slope form. Example number 6. Go and paste it, copy example number 6, and we can work it out together. Go and pause it. Go and read through this and highlight the key things. Go and pause it. So on the first column, we have parallel lines, which only one of them is showing. So let's go and graph the second line. So I'm going to place one here. So that will be our second line. We know that the parallel lines have the same slope. This slope is 2 over 1, 2 over 1. So this will be 2 and over 1 as well. We know the all vertical lines are parallel. And we know the parallel lines have the same slope, correct? Perpendicular lines form a 90-degree angle, and perpendicular lines have negative reciprocal slope. You also have to remember that whenever you have, in this case, we have the slope is negative 2, and the opposite reciprocal will be positive 1/2. There's going to be times that they'll ask you about the slope and perpendicular lines, and you have to remember that whenever you multiply two slopes that are perpendicular, or two lines that are perpendicular, if you multiply them together, it should always give you -1. So that's a key concept that sometimes that appears on your UICTs. So whenever you multiply the slope of two lines that are perpendicular, should always give you -1. Do you agree? And we know that the vertical lines are perpendicular to horizontal lines. So example number 6. Take the time to find the equation line that passes through a specific point, 3, 5, and is perpendicular to the equation 2x plus 5y equal to 4. So find the equation of the line, go and pause it, and see what you get. Got it? So in this case, I know that they're perpendicular. The line that I'm looking for is perpendicular to this line here. And since they're perpendicular, I know that the slopes are the negative reciprocal. So I'm going to find the slope. And what can I do to find the slope? and you can solve for y. So therefore, it'll be 2x plus 5y equal to 4. So it will be 5y is equal to negative 2x plus 4. So therefore, y is equal to negative 2 over 5x plus 4 over 5. But the only thing I'm concerned about, or what I need this is to be able to find the slope of my new equation. So therefore, the slope for my new equation will be the opposite reciprocal, that's, or the negative reciprocal, that's a negative, becomes a positive, and that'll be 5 over 2. And now I'm going to use the point that's given to me, and I'm going to use my point slope for y minus y1, which is 5. My slope is 5 over 2. X minus x1, which is 3. Go and solve for y and see what you get, and then we can compare our answers. Go and pause it. So therefore we have y minus 5 is equal to 5 over 2x minus 15 over 2. Plus 5 on both sides. Now when I add 5 in here, I need as over 2. So therefore I know it's going to be, how many halves are in 5? 10 halves. So therefore y is equal to 5 over 2x minus 5 over 2. And let's go to the decimals and just confirm that that is correct. So decimals is a very nice way to be able to graph. And what's nice about decimals is that you can actually type in your original function in standard form, 2x plus 5y equal to 4. And I can type in my other equation, which is y equal to 5 over 2x minus 5 over 2. On your graphing calculator, if you want to graph this equation, then you have to solve for y. So you'll have to type in this instead before you can actually tell. And notice that in this case, does it go? The new line is the blue line. It does it go through 3, 5, and it does, and it does look to be perpendicular, correct? Example number 7. Go ahead and take the time to copy it down or paste it, and then we can continue once you are ready. Go and pause it. Projection for net Medicare spending in billions of dollars are shown in the table. So in 2018, the cost was $574 billion of the Medicare program. 2019, $642 billion, and it's projected to continue to increase. Use a graphing utility to make a scatter diagram of the data, where we're going to let x equal to 0 correspond to 2018. So let's place a 0 right next to it. X equal to 1 to 2019, and so on. So that'll be 2, 3, 4, and 5 will correspond to the 2023. Let's go first use your graphing calculator. So I'm going to turn on my graphing calculator, and you probably have done this before or last year in Algebra 2. If not, let's go through the process. I want to go and enter the data, where this will be my x value and this will be my y value. I'm going to go under stats, which is right here. And then I want to edit the first list, so I'm going to click on 1. Now, if there's a list already there, you can just go move up, and then clear, and then press enter, it'll clear for you. I'm not going to enter the numbers, so in this case, I don't want to enter the year, I want to be able to enter the corresponding number. 0, 1, 2, 3, 4, or is it 3? And I can clear them. Then from here, I'm going to type in my cost. Will be 574, 642, 688, 738, 833, 852. And this is something that we are going to be doing throughout the school year, we are going to be using scatter plots and regression to be able to find the equation of the line. So first, let's go and graph it. Now, notice that if I graph it, nothing appears. Oh, actually, there's a line in here, but I think that's the line that I had before. I'm going to click on Y, and that is the line I used before, so I'm going to clear it. Make sure there's nothing there. You want to be able to plot the point, so therefore, I'm going to go all the way up. I'm going to press Enter. And then I'm going to click. If you notice that if I go down, it's already highlighted. So to get to this menu, you click on Y, and that gives you this menu. Make sure that the plot 1 is highlighted by pressing going up and pressing Enter, or you can disable as well. But let me go up, press Enter, go down, and I know that the plot is ready to graph. I'm going to press Graph. And notice that nothing appears. So one of the things that we want to do, we want to be able to adjust our viewing window. I'm going to click on Window. And what is the smallest value that we see? It goes from 0 to 5. So I'm going to go from -2. I also want to be able to leave some space before it. All the way down to 5 will be the maximum. Scale will be 1, should be fine. Then Y minimum, what is the lowest value? 574. I always want to be able to see a little bit before, so I'm going to click on 500. And it goes all the way to 852. So let's go and go up to 900. And now if I graph it, I should be able to see those points. Now notice that I still see a point beyond. So let me go in Window and let's go and do 1,000. So you want to kind of play around with your setting, your window, your minimum, your maximum for your X. The scale is half, and you want the little lines. You can, but for now I'm just going to leave it for 1. And I can still see it there. Let me go and click 1200. Oh, no, it's not going to be. I'm adjusting the Y values, right? If I want to be able to see beyond for the window, I'm going to be able to change it to maybe 7. And now you can see that it goes from -2 all the way up to 7. That's a form a line. So therefore, if you can imagine a line going through it, yeah, correct. So the answer is the data approximately linear? Yes. You don't have to sketch the scatter plot. Now find part B. Find the least square regression. And this is the equation. And most of the time I'm not giving the equation just because once we go into decimals. The models that Medicare spending. So to be able to find the least square regression, basically we want to be able to find the line, the equation of the line, and that's what regression is. It's called least square regression, but you're going to see more of this terminology once we go into stats, or once you take stats class. And I'm going to go over this briefly once I go into decimals. So I want to be able to find the equation that best models this 0 points. And the graphing calculator can do it for you. So what we want to do, we want to go into stats, calculate. Then I'm going to linear regression, which in my case is line number 4. And I'm going to press enter. List 1 is my X value. Now this corresponds to the list that we have. So if I go into stats, edit, that's list 1, that'll be your X. That's list 2, that'll be your Y. Let me go under stats again, calculate, regression, linear regression. We'll be using the other ones as we go throughout the school year. X are your L1 values, your Y values are your L2 values. We're going to leave this blank. Now we want to be able to store the equation, so that way you don't have to retype it. So what I'm going to do, I'm going to go on the vars, then I'm going to go on the Y vars, go to the right. Notice that number 1 is a function, and I'm going to select number 1 for y1. So that way it stores it in the first equation. I'm going to go down and I'm going to go and calculate. If you have a different calculator, you can always email me and walk you through the steps, or I'll send you a quick video, or I can walk you through it in class. And that's basically the equation. So let's go and write it down. For first A, are the data approximately linear? Yes. The data it approximates seems to be linear. Or approximates a linear function. B, find the least square regression. So therefore, your M, if you notice, that is your A value, which is so y equals. I just need two decimal places, so it'll be 57.51 x plus b, so it'll be plus 577. To the decimal places, 48. Now, if I want to graph it, what I want to do, because we saved it into a function, if I click y equal to, notice that that's already placed in there with all the decimal places. And then I can just graph it. And notice I'm going to graph your function. No, that doesn't help much. So that is the equation of the line. That is the equation of the best represents all those points, and that will approximate any value. Now, let's go to letter C. Use f of x to project Medicare spending in 2024. So therefore, if Medicare spending, I'm going to 2024 will be 6, with the next point, 2024. So what I'm going to do, now I'm going to calculate, I'm going to use the calculation. If you notice on top of trace, you'll see calculate. So I'm going to second calculate, I'm going to calculate the value, number 1. And I want it to be now 1x to be 6. And that gives you the projection, which will be 922. So in 2024, we can project the cost for Medicare to be 922 billion, and that's in dollars. Now, let's go into decimals, because if you don't have a calculator, you can also use decimals. And decimals does a really good job of being able to calculate other values. So therefore, let me go click on the plus table. And I'm going to type in the table 0, 1. And if I press enter, I can go down all the way down to, let's go down all the way down to 5. And type in the other numbers. 574, 642. And you want to be doing this as well, because you want to be able to get used to using decimals. You'll be able to use it for your SBAC. It allows us to be able to do a little bit faster calculations. Now, to be able to do regression on decimals, I'm going to type in y, but because this is y1, I'll press a 1 afterwards and place as a subscript. Instead of an equal sign, I'm going to press this symbol here, which is on top of the tab. To make sure you press shift. Then I'm going to type in mx. I'm going to press a 1 for the x1, so it matches these numbers here, plus b. And notice that the numbers that you get are exactly the same ones that the graphing calculator does. But it also gives you the r that we'll talk about more in your next example. And notice that it gives you the r square. That is the least square regression. So we want to be able to make sure that this number gets closer and closer to 1. That means that's going to match all of your points. But we see no points plotted here, right? So let's go into your window, adjustment, graph settings. And it's going to match the other settings that we had, which was -2, We want to go up to probably like 7. 6 is fine. 10 is fine. I'm going to tap to get to my negative. On my Y, I'm going to change it to. Usually on decimals, I prefer to see it my x-axis. I'm going to go from negative 100. Let's see it all the way up to 1000. I would like to see my x-axis if I'm using decimals. On the graphing calculator, it's a little more challenging to see because of the small window. Now you can see all the values, and now you can see the line. And notice that it does go through most of the values. And in stats, you'll be able to see your residuals, which will be the difference from each of the points to the line. But for now, we don't have to talk about it. We just need to be aware that it's a 98% accuracy of the projection, which is pretty good. And if I want to be able to calculate the value, then in decimals, I have to actually just type in the equation. I can type in as a function. Um, no. So there's things that the graphing calculator does really well, and there's things that the decimal does a little bit better. For that, I need to be able to type in my equation over the line. But for now, let's continue to example break. We'll come back to that later in the school year. That's example for today.